Now we are looking at removable media. Floppy drives were the first type of permanent storage in most personal computers. The last generation of floppy disk, the 3.5-inch floppy disk, is a thin, flexible, magnetically coated mylar disk. In other words, that's why we call it a floppy, encased in sturdy plastic. The storage capacity is 1.44 megabytes. The surface of the disk is accessed by the drive when the metal cover slides open as the disk is put into the drive. The read-write heads on the drive can then read existing data or write new data to the disk. When a drive is busy with one of these activities, the drive LED lights up. A disk should not be removed when this light is lit, or data damage will occur. Since the first PCs had no hard drives, the operating system and any data was stored on floppy disks read by the system's floppy drive. This drive was always referred to as Drive A. Now, it quickly became apparent that only one drive in a system meant an awful lot of floppy swapping, so a second drive was added, known as Drive B. These two drive letters are still reserved by BIOS and Microsoft operating systems solely for floppy drives, even if no floppy drives are physically present in the system. Traditionally, the assignment of the drive letter to a drive depends on where on the data cable the drive is connected. A floppy drive ribbon cable has 34 pins and often comes with 3 connectors, one for drive A, one for drive B, and one for the controller on the motherboard or controller expansion card. The drive A connectors, the drive A and B connectors are distinguished on the cable by means of a split and twist in the cable. This is not a defect. The connector closest to the split and twist designates that connector as being for drive A. This is the connector at one end of the cable. The connector in the middle then is for drive B. The remaining connector is for the motherboard controller. Now, you may also see cables which leave off the drive B connector entirely, and these cables may not have a split and twist. One end would be for the drive, the other for the controller. In any case, connect these cables properly so as not to confuse the PC or other users. The other thing to remember about installing the floppy drive cable is the red stripe rule. If the red stripe is not to pin end on either the end of the cable, the floppy drive LED comes on during boot and stays on. If you try to access a disk in the drive at this point, you will get an error message. So to summarize, the two rules for attaching floppy drive data cables are: drive A is connected closest to the split and twist in the cable, and the red stripe to pin 1 or closest to the power connection on the drive. Power for the floppy drive is supplied by one of the two small mini connectors called Berg connectors coming off of the power supply. These are keyed, so they have a ridge on the top of the connector that shows the up position. Be careful when installing these power connectors. It is possible to put the connector on upside down or to miss one of the pins entirely. If you do this, it will apply power to the wrong wires in the drive and it will burn out the drive, literally. It can even ruin your power supply or your entire system. Always make sure you have the power and the drive cables installed properly before you turn on power to your system. Configuring your system to recognize a floppy drive is pretty basic. CMOS will typically have a floppy drive setting where you would choose the capacity for drive A and maybe for drive B. The default is 1.44 megabytes, 3.5 inch, and you shouldn't ever need to change it. It is possible to disable these drives in CMOS as well. If you have no internal floppy drive in your system and you would still like that functionality, you can get an external USB floppy drive. If your BIOS supports USB devices as boot drives, this can be used with a bootable drive disk to start up your system. The most recent easily readable and writable removable media with increasing capacity is flash memory media. This category includes thumb or flash drives and flash memory cards. Flash memory cards became popular as a way to take and store more photos when using digital cameras. Many PDAs and cell phones have also used them to increase storage capacity. These cards appear in several different formats, most recognizable by their brand names or abbreviations: Smart Media, Compact Flash, Secure Digital, Memory Stick, and XD Picture cards, for example. To retrieve data off of one of these cards requires a card reader. PCs today may come with a card reader installed. Photo printers also often have a card reader built in, so no PC is required in order to print photos from the media in your camera. If you don't have either of these, a USB card reader is just what you need, and they often come with a USB floppy slot as well. Even if you don't use flash memory cards, you probably do use flash media in the form of flash or thumb drives. With the removal of floppy drives from PCs, flash drives have become the easiest way to save, store, and transport files. They are hot swappable in Windows. Flash drives can plug into any USB port on your PC, and it's not uncommon to have more than one connected at a time. It used to be that you could tell any geek by the pocket protector in his or her shirt. Now just look for the flash drives. These devices require no external power source. They draw power through the USB port. Since the memory is solid state, the drives are shock resistant. The biggest threat of lost data comes from losing the drive itself. Another advantage of flash drives is that they have cross-platform compatibility. You can transfer a file from your Windows system to a Mac or Linux system, or vice versa. Today's computer systems enable you to boot from a flash drive if it contains boot code. Another use is to actually run applications that are installed on the flash drive. The app does not need to be present on the hard drive. Compact discs began to be used in PCs shortly after Windows 95 was released around 1995. It took about 20 discs to hold that operating system, and it took quite a while to install what was swapping all of those floppies. Optical CDs could easily hold that amount of data. More recently, digital versatile discs have replaced VHS tapes. These have a larger storage capacity than CDs, which makes them appealing for data backup and other high-capacity storage needs. Both of these types of disks and their drives are collectively referred to as optical media. This category includes CD-ROM, CDR, CDR-W, DVD-ROM, DVD-R, DVD-RW, DVD plus R, DVD plus RW, DVD-RAM, Blu-ray DVD, and readable and writable Blu-ray. The first CDs were originally used for music in a format called CD audio. When CDs began to be used for data, the drives read at a speed of 150 kbps, the same as was used for playing music. Now this was a great speed for music, but pretty slow when installing software off of a CD. So quite soon, drives were in use that read data much faster, in multiples of that 150 kbps speed. This was designated in the drive specs by saying things like 4x or 32x or 60x, meaning that many times faster than 150 kbps. Now, data on a CD obviously isn't installed in CD audio format. Rather, CDs have a file system all their own called ISO 9660, also referred to as CDFS, or CD File System. But how is information actually stored on and read from a CD? Data is stored by means of pits, or recessed areas, and lands, or non-pitted areas. The laser in the drive reflects off of these surfaces, and the controller interprets these different reflections as the ones and zeros that your system recognizes. CDs have a reflective metallic coating over this pitted surface, and this in turn is protected by lacquer. The data is actually stored near the top or the label side of the CD, so be careful there when handling the disk. CD-ROMs store about 650 megabytes of data on average. Now, it didn't take long before people wanted to use CD media the way that they used magnetic media, not only to read from, but to write to. Traditional CD creation methods were not suitable for standard PC use, so new technologies were devised so that the user could write their own data. The first of these was CD recordable, or CDR technology. These special drives recorded data onto CDR disks by using a burn laser to heat the organic dye coating the disk. This would change the reflectivity in areas which the read laser then would read the way a standard CD-ROM drive does. There were two speeds associated with CDR drives, the burn speed and the read speed. These again are both multiples of 150 kbps on CD-ROMs. The drawback to CDR is that data cannot be erased or changed once it's on the disk. CDR drives are not often found, although CDR disks are prevalent. Systems offer CDRW drives instead, which would allow rewriting onto CDRW disks, so the same disk could be written to, erased, and written to again. The technology is similar to CDR drives, but CDRW disks have a surface consisting of a non-crystalline substance that becomes crystalline and reflective when heated. CDRW drives use a special format called Universal Data Format, which allows packet writing. In Windows, this lets you drag and drop files from your hard drive or other media to your CDRW disks, just as you would with other removable media. To burn a bootable CD, you typically needed a three-party program. CDRW drives had three speeds: the write, the rewrite, and the read. There's a wide variety here among the various types of drives, so that it paid to shop for a drive speed considering how you most likely used it. DVD technology is much like CDs, except with a much greater capacity. This makes it ideal for video. DVDs accomplish this higher capacity by using smaller pits and packing them more closely together on the disc. They can also use both sides of the disc media, and they can put two layers of data on each side. Data storage capacity for DVDs ranges from 4.37 gigabytes up to almost 16 gigabytes, or more than 8 hours of video. To achieve such high data capacities, DVD video relies on the MPEG-2 standard for video and audio compression. DVD-ROM is the DVD data equivalent of the CD-ROM format. Most DVD-ROM drives support DVD- video as well as standard data and music CD-ROMs. As with CD technology, burning technology is now also available for DVD and Blu-ray. DVD-R and DVD+R are like CDR, writable but not rewritable. DVD-R, W, plus RW, and DVD-RAM can be written and rewritten too. Now, unfortunately, there's never been a definitive standard, but manufacturers have now come out with combo drives that can write to all the common formats. To read all of these formats, you'll usually get a DVD multi-drive, which can read all DVD discs as well as all types of CD discs. Blu-ray is the technology that will probably make CD and DVD media and drives obsolete. The standard size single-layer discs can store up to 25 gigabytes and dual-layer discs up to 50 gigabytes. Mini discs have a smaller capacity and are mainly found on high-end camcorders. Because Blu-ray uses blue-violet lasers instead of red lasers the way DVDs do, it can handle high-definition resolutions. The blue-violet wavelength is smaller and more precise as well, so it uses disk space more efficiently. The formats for Blu-ray are BD-ROM, BD-R, and BD-RE. Blu-ray burners are still a little bit expensive, but more than likely will become more common and lower priced. BD and DVD drives are virtually physically indistinguishable from CD drives and install and are used the same way. Your PC will recognize them as a DVD rather than a CD drive, but otherwise they operate the same. Most optical drives today are a TAPI, ATAPI, or AT Attachment Packet Interface. This is the standard that allows optical drives to be connected to a system just as ATA hard drives are, either through PATA, IDE cables, or SATA. So a PATA optical drive has a 40-pin controller on the drive, as well as jumpers to designate it as master, slave, or cable select. The typical practice is to set an optical drive as slave to a hard drive master on the same cable. If the optical drive has SATA connections, it gets its own direct connection to the system via a SATA cable. Once the drive is properly connected and powered, Drive BIOS reports to CMOS the actual drive information, so this will show up in setup. The drive should also appear in Computer and Device Manager. Windows will automatically detect a disk inserted into an optical drive using a feature known as Auto Insert Notification, what we more commonly refer to as autoplay. Typical problems with optical drives include improper installation of things like cable and power connections, dust and scratches, and user error. Make sure the drive is properly installed and boot. If the drive does not show up in CMOS or My Computer, check the cable connections. Scratched or dirty disks are hard for drives to read. Clean a disk gently using a cloth moistened with water, maybe with a little detergent added. Don't use alcohol or other cleaners. They will damage the surface of the disk and make the disk unreadable. User errors ranges from accessing the wrong drive, in other words a drive that has no disk in, to getting disks stuck in drives. Most drives have a manual eject pinhole. The system should be off before attempting removal of a stuck disk with this method. When using burners, you may run into buffer underrun. This is caused by the inability of your source device, whether that's a hard drive, another optical drive, or whatever, to keep the burner loaded with data during the writing process. Burners should have enough buffer space to store enough data while writing. There are no drive upgrades for drive buffer space. Multitasking is another thing that can cause buffer underrun. So burner drives now offer burn-proof technology designed to eliminate the underrun issue. They will turn off the burn process if the buffer empties and then restart it when the buffer refills. With this technology, you can burn optical discs at the same time you use your PC for other tasks. To burn bootable disks, you generally need a third-party tool such as Nero or Roxio. One of these programs will make a perfect copy of a CD or DVD, such as an installation disc. The special file types of these disks are known as ISO images. Many optical media drives come with an upgradable flash ROM chip. Updates on the manufacturer's website could help if you can't read a particular type of media. It's not uncommon for these updates to come out as advances are made in the technology, and it can save you from having to buy a new drive. A really good reason for using removable media is for data backup. Once you've created data files, there's one more thing to remember. If you can't get along without it, back it up. There are, in general, 4 different groups of files you may want to back up. Now, these categories overlap in some cases, and there may be things you would add or not back up on your system, given how you use it. The first category would be your personal data files. Next would be personal data used by applications. Then the current system state files. And lastly, you might back up the entire hard drive. There are several different ways or media that you can back this data up to, including network drives, burners, flash drives, or an external hard drive. Removable drives are popular for PC backups because they can be used for backup as well as other things, and the prices are affordable. CD and DVD RW media can be reused several times, which makes them attractive for rotating backup methods. CD or DVD-R is useful for one-time backups or for archiving data. Flash drives are another type of storage where files can be saved for short-term backup or for moving data from one PC to another. The most basic backup method is to copy a file from your hard drive to some other kind of media, but we don't always remember to do that. One solution is to set up the system so that the backups can occur at regular intervals. Scheduled backups can be performed without user intervention at regular intervals, such as every Friday night. Remember that you can only back up files that are not being used, so close all files before performing a backup. Windows 7, 8, and probably 10 have a backup and restore applet. This enables you to back up selected files or your whole computer, or to restore from one of these backups. The availability and low cost of external hard drives has made this a very reasonable option to use for data backup. It's worth investing one that would comfortably hold a backup file of your entire hard drive, or even better, a disk image of your hard drive. There is a difference between the two. To restore a backup file from a drive, you need to be able to boot up the drive, usually with your operating system media. If you don't have that, it's more complicated. The backup utility in Windows seems to assume that you'll be able to get to that utility in order to do your restore. In the case of a hard drive failure, this isn't going to happen. In this case, it's better to have a disk image on another hard drive. Windows 7 and later operating systems include an imaging program to do this. If you have an earlier version of Windows, you can get a third-party program to create a system image of your machine. For a long time, Ghost was the program widely used to create and restore disk images. Then XP came out, Ghost was bought by Symantec, and the program became known as Norton Ghost. There are other disk imaging programs available. Some may even be free, but I'd hesitate to trust my hard drive to them. Some of those you can purchase will let you download a trial version for trying out the software on your own system. If it works for you, you should buy it if you intend to keep it. I found Acronis TrueImage to be a good program for this. You can create an exact bootable replica of your hard drive on another internal or external hard drive or to a network drive. Most images are going to be too large to burn to a CD or a DVD, so a hard drive will be your best bet for storage. In the case of your main hard drive failure, you'd simply install your image drive, boot from it, and move on with very little inconvenience, depending on how old or new your image is. So again, just remember, better to back up sooner rather than later.